Assalamu alaikum viewers. Bismillahirrahmanirrahim. My today's topic is types of matrices. Here are types of matrices. First is row matrix. A matrix is called a row matrix if it has only one row. Okay. Which matrix is called row matrix? Which has only one row. For example, the matrix M is equal to this is the way how we can write the matrix 2 minus 1 7 is a row matrix of order. What is the order? First we have to see that how many rows are there. One row and three columns. So its order is 1 by 3. And let's see another example. M is equal to 0 minus 1 is a row matrix of order 1 row and 2 columns, so its order is 1 by 2. Now look here, if we have matrix like this 0 2 minus 1 3 2 4, this matrix has 2 rows, so this is not a row matrix. What is the definition? If the matrix has only one row, that is called row matrix. So this is row matrix, but this is not called row matrix. Now come here. Next is column matrix. A matrix is called a column matrix if it has only one column. For example, M is equal to, this is a way to write matrix. Here we have only one column. Okay, and look at this we have 2 0 1 are column matrices of order. Its order is, here we have 2 rows and 1 column, so its order is 2 by 1, and here we have 3 rows and 1 column, so its order is 3 by 1. Now look at next what we have here, a null matrix or zero matrix. A matrix M is called a null or zero matrix if each of its entries is 0. Okay, now look here. Here we have square matrix and its all entries are 0. And here we have row matrix and here we have column matrix and its entries are 0 0. So this is called zero matrix. Okay, no matter what is the order of matrix, if the entries are 0, then we say this is zero matrix. Now next type is transpose of a matrix. A matrix obtained by changing the rows into columns or columns into rows of a matrix is called transpose of that matrix. Now how we represent it, look here. If A is a matrix, then its transpose is denoted by A, and here we have to write small t in the power. Now look here, look at the example. If A is equal to this matrix, then we have to take its transpose. How we can take its transpose? We have to change the rows into columns. Now look at first row here. What we have? 1 2 3. We have to make it, what we have here, what is our first row, make it, write it as column 1 2 3. Now look here, what we have here, 2 1 0. Now write it again as column 2 1 0. Now look here, minus 1 second, minus 1 4 minus 2. Here write minus 1 4 and minus 2. This is the way. Now look here, we again get the same matrix as A. Okay, so this is called transpose. AT is equal to this. If a matrix A is ordered 2 by 3 and then order of its transpose AT is 3 by 2. Now next is negative of a matrix. Let A be a matrix, then its negative minus A is obtained by changing the sign of all the entries of A. That is, if A is equal to 1 3 minus 2 4, we have to change the sign of all entries. Look here, we have positive 1, we have to write it minus 1, here we have minus 2, so it will become positive, and here we have positive 3, it will become minus 3, and here we have minus 4, so it will become minus 4, and we have to write minus with this name of the matrix also. This is the name of the matrix, minus A is equal to this. Now next we have symmetric matrix. A square matrix is symmetric if it is equal to its transpose, that is matrix A is symmetric if AT is equal to A. Okay, when matrix is symmetric, when we will take the transpose of original matrix and it again equal to original matrix. Now look here, if M is equal to this matrix we have is a square matrix, then what we have to do, we have to how we can take the transpose. We have to change the rows into columns. Look at first row, make it column, second row make it column, third row make it column, and again we get the same original matrix. Can you see here, when we take the transpose, when we have taken the transpose, we get the same matrix, original matrix, so M is symmetric. Now look at this example. If A is equal to this matrix, then take its transpose, make this row as column, this row as column, and this row as column. Now can you see here some entries are different. Here it is 1 and minus 1, minus 1 1, here we have 2, so it is not equal to original matrix, hence A is not symmetric. In this case A is not symmetric. Now next look here, what we have, scalar matrix. A diagonal matrix is called a scalar matrix if all the diagonal entries are same and non-zero. Diagonal entries must be same and non-zero. Look here in this example, what we have, diagonal matrices are same and non-zero and other entries are 0. In here also we have diagonal entries same and non-zero and other entries are 0. And what is the order of this matrix? 3 by 3, and its order is 2 by 2. Now next look here, what we have, identity matrix. A diagonal matrix is called identity, or we can say it unit matrix if all diagonal entries are 1. It is denoted by this capital I. For example, A is equal to, look here, what we have here, it's all diagonal entries are 1 and other entries are 0. And this is a matrix of order 3 by 3. Here this is the matrix of order 2 by 2, and this one is 1 by 1. And this is called identity matrix. Now next look here, what we have, skew symmetric matrix. A square matrix A is said to be skew symmetric if AT is equal to negative of original matrix. It means negative of A. Okay. Look here, if A is equal to this matrix, then we have to take its transpose. What is the transpose? Make this row as column, make this row as column, make this row as column. Now can you see, when we take this minus, what we have, minus A is equal to minus A. When we take minus as common, so it will become, look here, here it is minus, so it will become positive 2, it will become positive 3, and it will become minus 2, and it will become plus 2, it will become minus 3, and it will become minus 1. So what we get, this is the original matrix A. Can you see here? Can you see this? These both are same. And what we have done, we have taken this minus sign as common. So what we can write, this minus A. So A is equal to A of AT is equal to minus of A. So this matrix is Q symmetric matrix. Now next look here. A square matrix A is called a diagonal matrix if at least one of the entries of its diagonal is not 0 and non-diagonal entries are 0. If at least one of the entries of its diagonal is not 0, there is no condition that it must be same. It can be different. Diagonal entries can be different but non-zero, and other entries are 0. So its order is 3 by 3, and here what we have, its order is 2 by 2. Can you see these diagonal entries are 2 and 3 and other entries are 0. So thanks for watching my video. If you like my video, don't forget to subscribe my channel, like and share this video to others as much as you can.